In this video, we are going to study the periodic classification of elements, how the elements are classified. So, in the ninth class, we have learned that the matter around us is present in the form of elements, compound and mixtures. An element contain atoms of only one type. So at present we have 118 elements discovered, and out of these 94 are naturally occurring elements, and different elements have been discovered. Scientists gather more and more information about the properties of these elements. They found it difficult to organize all that we know about the element. So it was very difficult for organizing the element. So looking for they started looking for some pattern in their properties, and on the basis of which they could study such a large number of elements with ease. So they started finding patterns in these elements, and so that they can categorize, or you know can make a proper classification of these elements. So the first thing was the early attempt from the classification of the atoms. What are the early attempts? Scientists made several attempts to classify the elements according to their properties, obtained an orderly arrangement out of chaos. So there was a chaos, like elements were randomly discovered, and some elements were element discovered first. So there was a mixture of element. Nobody knows how to classify these elements. So what did these earliest classification was by the grouping the elements as in metals and non-metals. This was the earlier classification where we grouped metals, just two things: metals and non-metals. In the earlier classes, we have already studied metal have a luster, metal have a sign, metal has a property of ductility, and they conduct electricity and all that. And wherever non-metal and also metals are supernovas. And on the other hand, non-metal have a quite opposite properties of metals. They don't have much structure, they don't have a ductility, they do not conduct electricity. So these were the properties of non-metals. So based on these properties, uh, the early classification was done. Then afterwards there was a scientist, and we will study this guy, and he was a German chemist, and he also tried to arrange the group of elements. So his arrangement is called Daubeney triad. So triad means three. So what he did, he classified animals into three groups. So he identifies some groups having a three element each. He called them triad, and triad were written in order that increasing atomic masses, and atomic masses of the middle element was roughly the average of the atomic masses of the two other elements. So simply he just grouped the elements into three categories, and on the basis of the increasing atomic mass of the A, B, C. Atomic mass of the B is roughly equal to the average of atomic mass of first and second. This is what he did in, and he arranged elements in the group of three, and these are known as triads. And This is an example, and take a triad consisting of lithium, sodium, and potassium. So he also made some. These are the triads groups. Atomic mass is increasing, and the middle element has a roughly equal mass of the average of the first and third. You will see from the group B and C from the Dobinier triad, and the Dobinier could only identify only three triads. So he could only identify three triads. That means only 9 elements. This system of classification into triad was not found useful. So these were the only three group of element that he can like classify into. And the next classification after the series in the series of development making for the classification of elements comes given by the Newland, and he gives law of octave. So what he did in 1866, John Newland is an English scientist. Arranged the then known elements in order of the increasing atomic mass, and the lowest atomic mass of the hydrogen. We started with the element having the lowest atomic mass, hydrogen, and ended with the theorem, which was the 56th element. He found that every 8 element has a property similar to the first of that of first. So compare this with the octave found in music. He gave a law which is called law of octave, also known as Newland's law of octave. Newland's octave law. In Newland's octave law, the property of the lithium and sodium were found to be same, and sodium is the 8th element after the lithium. So what he did, he arranged elements in a way that he found that the 8th element has a same or similar property of the first element. So based on a musical note, he gave this classification as an octave law. So what he did, he grouped the element into 7 category: 1, 2, 3, 4, 5, 6, 7, and 8th one has a properties of first one: 8, 9, 10, 11, 12, 13, 14. So he grouped the element into 7 groups, and the 8th one again has a same property of the first one, and this is how the musical notes are, and this is why he named it as a law of octave. There is a like this is chart for it, and there are 7 elements. He grouped this way: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, and again fluorine, nitrogen, magnesium, aluminum, silicon, and these. So this atom has a property of similar to this one. So it was found that the law of octave was applicable only up to the calcium. So there are some limitations of this law, what this law could not explain. It was only applicable up to the calcium, and after the calcium every 8 element did not possess the property similar to the first one. And also it was assumed that by the Newland that only 56 elements exist in the nature, and no more element would be discovered in the future. But later on several new elements were discovered whose property did not fit with the law of octave. So this was the another limitation of this law. And in order to fit the element into the table, Newland adjusted two element in the same slot, but also put some unlike element under the same node. So to make just headers, he also put the same two element uh, in a same set. Iron, which resembles cobalt and nickel in the properties, has been placed far away from these elements. And with the discovery of a noble gases, law of octave become irrelevant. Thus, the Newland's law of octave worked well with the lighter elements only. So it was working with the lighter elements only. It was not working for the heavier elements. Then after this, another guy, Mendeleev, who was from Russia, again tried to arrange the elements. So let's study about the Mendeleev periodic arrangement. The main credit for classification of element goes to the Demis Ivanovich Mendeleev. He was a Russian chemist, and the elements were arranged on the basis of the fundamental properties, which is the atomic mass, and so on the similarity of the chemical properties. So two things, on the first on atomic mass and also on the similarities of chemical properties. So when Mendeleev started work, only 63 elements were known, and Mendeleev concentrated on the compound formed by element with the hydrogen and nitrogen. The formulae of the hydrides and oxides formed by the element were treated as one of the basic properties of the element for its classification. Elements were arranged in order to their increasing atomic masses, and it was observed that there occurs a periodic reoccurrence of element with a similar physical and chemical properties. On the basis of Mendeleev formulated periodic law, we state that the properties of element are the periodic classification of atomic mass. This is the most important statement. Like, what are the properties of elements are the periodic function of their atomic mass. So he arranged elements on the basis of their atomic masses. So what are these properties? Properties were, he classified into what he understood by property is the forming the hydrides. Hydrides and oxide formed by the element were treated as one of the basic properties. So these were the properties inter alia with the others, and he concluded that these properties are the of an element are the periodic function of their atomic masses. And Mendeleev periodic table contains vertical columns which are called groups. These are the vertical columns, and horizontal columns are called periods. These are the periods. This was the Mendeleev periodic table. He has like 8 groups and 6 periods. What are the achievement of the Mendeleev and what are the limitation of the Mendeleev? What are the achievement? Mendeleev left some gaps in the periodic table. Instead of looking up these gaps as a defect, Mendeleev boldly predicted that the existence of some element that has not been discovered at that time. So he predicted some elements. Suppose there are some gap in the periodic table so he predicted there must be some element in there which has not been yet discovered, and Mendeleev named them by prefixing the Sanskrit numeral ikka to the name of preceding element on the same group. For instance, scandium, gallium and germanium discovered later has a properties similar to the Ika boron, Ika aluminum and Ika silicon respectively. So here Ika means plus 1, 1 next to that. Suppose this is a element X, so and this is the uh, maybe, so it is unknown element, so he gave it the Ika X, Ika X, and these are also have a name. Suppose it is a Y, Z and suppose A. So the element which was not undiscovered, he named it Ika X, the preceding suffixing this way. And these are the property he also predicted. Ika aluminum, which is later known as a gallium, the atomic mass, what is predicted and what actually is. In formula with oxide, it is exactly forming with the oxide. Ika 2, which is gallium, which was later found as 2, combining with the 3 molecules of the oxygen, and formula for chloride was exactly same. So he almost predicted similar properties and atomic mass. These are the two properties of forming chloride and oxide are similar, all are same, almost it is same, and the atomic mass is similar, almost same. Noble gas like helium, neon and argon have been mentioned in the many contexts before this. These gases were discovered very late because they are very inert and present in extremely low concentration in our atmosphere. One of the strengths of the Mendeleev periodic table was that when these gases were discovered, they could not be placed in the group without disturbing. They could be placed in a group without disturbing the existing one. So one of the basic things was one of the best properties of this classification was like he arranged in a way that even though there are gaps, he left the gaps, and he thought that the if the when the still there is some element there and that has not still discovered, and even after when the noble gas were discovered, which were discovered late because they don't found atmosphere too much, they are in the very low concentration, the we don't have to change the periodic table, they fit it in the periodic table without doing any disturbing the order. But there are also some limitation also. Let's discuss about the limitation. On the other hand, just like a halogen, electronic configuration of the halogens resembles that of alkali metals. Like alkali metals, hydrogen combines with a halogen, oxygen and sulfur to form a compound having a similar formula shown in example here. On the other hand, just like a halogen, hydrogen also exists as a diatomic molecule and it combines with the metals and non-metal to form a covalent bond. Certainly no fixed position of hydrogen was given. So in this classification there was no fixed position for the hydrogen in the periodic table. This was the first limitation of the Mendeleev. Hydrogen doesn't have any definite position in the periodic table. An isotope was discovered long after the Mendeleev has proposed his classification of element. As the isotope, what are isotopes? Isotopes are those which same elements having a element is same having a different masses. So as Mendeleev has arranged the table into increasing mass, so what would happen in this case? Thus, the isotope of the all element poses a challenge to the Mendeleev periodic law. Another problem was that the atomic mass do not increase in a regular manner in the going from one element to the next, and so this was not possible to predict how many elements to be discovered between the two elements. So three things to be concluded: 1, 2 and 3. First was like hydrogen, the place of the hydrogen was not fixed. Second thing, when the isotopes discovered later, so what happens as the mental leaf increase, suppose mental leaf 1 2 3 4, suppose these are the atomic masses on increasing orders of the different element, and isotopes are those elements, suppose like carbon carbon has a two isotopes. In one isotope it has a mass of 12, another it has a mass of 13. So there are some other isotope where suppose the element has a mass of like 35, and same element in a different isotope has a mass of 30, let's say 9. So what happened this, so suppose let's understand with the example. Let's 4 is an element, 4 is a mass of an element. It was earlier arranged in an increasing order of the mass. So 4 element, the mass, the element which has a mass 4 is arranged here. Later on it was discovered that this element, let's say x, are present in a nature in two forms. X, sometime x has a mass of 4 and sometime x has a mass of 6, because it present in a two forms. This is called isotopes. Isotopes are those who has the same atomic number, that means same number of proton but have a different number of neutrons. So because of the different number of neutrons, the mass is different. And suppose later on the another isotope of the X is found, so according to this should be placed here next to 6, because it had a mass of 6. So it was a limitation in this case. Now atom in this case was not fixed. If isotope were discovered later, so it can disturb the whole periodic table, because the mass of the new found isotope has changed. Okay, then another third limitation was that it was not possible to predict how many electrons could be discovered, as the atomic masses do not increases by the arithmetic progression. It is not by the 2 3 4 5 6. It goes like 1, then 3, then 5, then 6, then 9, and then maybe 13. So there is a lot of gap. There is no like regular arithmetic progression. There is no regular gap between the masses, like 2 is there, 2 is there, 1 is there, 3 is there, and this is 13, the 4 is there. So it was not possible ki how many elements are still to be discovered. So let's say 6 and 9 has a 3, 7 8 9. So it was not possible ki whether 3, whether 2, or whether only one element are still to be discovered. So it was still unpredictable ki how many element could be present between these two elements. So these are the three limitations of the Mendeleev. And let's talk after the Mendeleev. A new table was formed. This is the modern periodic table. We still use it. So this was the table elemental elements classification, and still this forms the basis of the modern periodic. This is the modern periodic table, and still the periodic table in our classroom that we are using is this modern periodic table. So let us study this final table. So in 1931, Harley Moseley showed that the atomic number symbolizes the Z of an element is a more fundamental property than the atomic mass. How? Because atomic number remain the same of an element. Suppose this element Atomic number is supposed 10, 10, 10, but mass number different. In some case mass can be 20, mass can be 22, mass can be 23. So he showed that the atomic number is a more fundamental property than the atomic mass, because mass is changeable, because they have a different isotopes, because of isotope. Accordingly, Mendeleev periodic table was modified. The Mendeleev periodic table modified, and the atomic number was adopted as the basis of the modern periodic table. And this atomic number was predicted as a base of the classification. So he stated periodic classification of properties of element are the periodic function of their atomic numbers. The properties of element, properties like forming oxide hydrides, like forming chemical bonds, these are the properties, or the chemical properties of the elements are the periodic function, the repetitive function of their atomic numbers. So this is how he classify. And elements when arranged in order to the increasing atomic number led us the classification known as the modern periodic table. So modern periodic table looks like this. This is the modern periodic table. And these are the metals, and these are non-metals, and these are metalloids, and they are arranged in an increasing atomic number. Like it has a 1 atomic number, it has a 2, it has a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, this way. And these are called groups. These are called groups, and group number, and there are 18 group. And these are the periods 1, 2, 3, 4, 5, 6, 7. There are 7 periods. This is the modern periodic table. And what we understood by the like periodic, this thing, properties of element are the periodic functions. So what are the periodic function? It has a periodic function like this, like property of hydrogen, lithium, sodium and potassium. These are coming under in a period, and they have a similar properties, and these elements have a similar properties, like these have a similar property, these has. Why these have a similar property? Because their valency is the same along with the others. Main thing is their valency. Their they have the same valency, same to form the outlet. So this is how the modern periodic table is like arranged. Okay, the position of element in the modern periodic table. There are 18 vertical columns which are known as groups, and 7 horizontal rows which are known as periods. These elements contain the same number of valence electron. You will find same number of valence electron. Element present in one group have the same number of valence electron. Each one group has the same number of valence. This group has the same number of valence. Valence is the same here. Valence is 1, and this last group doesn't have any valency because this forms the complete group. This valence is, its valency has a 0. So this is based on valency. And we can say that group in the periodic table signify the identical outer cell configuration. These say the identical outer cell configuration, and on the other hand the number of cells increases as we go down the group. Also the number of cells increases. Why? Because electrons are increases. there is an anomaly when it comes to the position of the hydrogen, because it can be placed either in a group 1 or group 7 in a first period. See, hydrogen have only one electron, so it has a one valency. So also these guys have also one valency, 17 group, and these have a complete valency. These also needs one electron to fulfill their outlet, the outermost cell. Atomic number, the number of valence cell electron increases by 1 unit as the atomic number increases by 1 unit on the moving from left to right of the periodic table. The maximum number of electron that can be accommodated by a cell depends on the formula 2n square, where the n is a number given to the cell from the from the nucleus. So K, L, M, and these are the cell. In K cell, there can be only two electron. In L cell, there can only be 8. Then comes M. M has a 2 into 3 square, which is 9 into 2 and 18. So M has 18 maximum electron. Then comes N, and 2 into 4 square, which is 16 into 2, 32. And N has a maximum number of 32. And this goes like this. The position of an element in the periodic table tells us about the chemical reactivity. Of course, why? Because the chemical reactivity depends on the valency, and they are placed in a way that each group have a similar valency, same valency. The valence electron determines the kind and a number of bonds it formed by the element. Atomic size. The term atomic size refers to the radius of an atom, and the atomic size may be visualized by as the distance between the center of the nucleus to the outermost cell of an isolated atom. That suppose, and this is the outermost electron, and this is a nucleus. So this distance is called atomic radius. The atomic radius of a hydrogen is 37 picometer. And you will see that the atomic radius decreases in moving from left to right along the period. This is due to the increase in the nuclear charge, which tends to pull the electron closer to the nucleus and reduces the size of the atom. More will be the nuclear charge, it has a more tendency to bring the electron closer to its nucleus, so size will be automatically reduced. And you will see that the atomic size increases down the group. Why? This is because the new cells are being added, so that as well as we go down, new cells are increased. Suppose hydrogen, lithium, sodium, potassium. So hydrogen only one electron, only one cell is there. Lithium has 2 cells, sodium has 3 cells, and potassium has a 4. So the atomic new cells are increasing, each like 1 plus 1 plus 1 plus 1. Every new cells are adding up, so that the size of the elements will increase. Metallic and non-metallic properties. Earlier, while we starting this chapter, we studied that the first metal was elements were divided into two categories, metal and non-metals. Now in the modern periodic table, elements are elements are classified on the basis of their atomic number. And now we are discussing their metallic and non-metallic properties. Metals like sodium and magnesium are towards the left hand side, and non-metals like sulfur and chlorine are the right hand side. In the middle there are metalloids which exhibits the some properties of both metals and non-metals. Here left hand side, let me show you. Left hand side are metals, right hand side are non-metals, and these are the metalloids, half metal and half non. They possess the properties of both metals and non-metals. Borderline element boron, silicon, germanium, arsenic, antimony, tellurium, polonium are intermediate in the properties, so they are called metalloids or semi-metals. As the effective nuclear charge acting on valence shell electron increases across the periods, the tendency to lose electron will decrease. And down the group, the effective nuclear charge experienced by valence electron decreases because the outermost electron are further away from the nucleus. Therefore these can be lost easily. Hence metallic character decreases across the period and increases down the group. Non-metals on the other hand are electronegative. They tend to form bonds by gaining electron. The oxide of the metals are basic, and non-metals are oxides of the non-metals are acidic. That we discussed in the previous chapter, in the acid and base chapter. Because when the oxides of the metal react with acid, they form salt and water. This is why if something is after reacting with acid forms salt and water, this must have the basic properties, and vice versa happens in case of non-metals, so they have a acidic character. So what we have learned, elements are classified on the basis of similarities in their properties, and Devonier grouped the element into triads, and Newland gave the laws of octave. Mendeleev arranged the element in increasing order of the atomic mass and according to their chemical properties. And Mendeleev also predicted the existence of some yet to be discovered element on the basis of her periodic table. Anomalies in arrangement of the elements based on increasing atomic mass could be removed when the elements were arranged in order to increasing atomic number, and this fundamental property of the element were discovered by the Moseley. And modern periodic table has 18 columns this way and 7 horizontal periods, and element thus arranged in modern periodic table, element thus arranged shows periodic properties including atomic size, valency, combining capacity, and metallic and non-metallic character by increasing them in a increasing atomic number. So I have drawn this graph. So first elements are classified into two, metals and non-metals, then three by the Devonier triad by increasing mass, where the middle element has a similar atomic mass of equal to the average of the first and third. Then Newland's gave law of octave, in which Newland arranged elements in a 7 category, 7 group, and eighth one has the similar property of the first one. Then Mendeleev came, he arranged an increasing atomic mass, and modern periodic table, which was like classified by Moseley, it was based on the increasing atomic number. So thank you for watching this video.